Hey, eighth grade. So our learning target today is I can display data in a scatter plot. So we're going to include scales, labels, and a title. Very important pieces of a scatter plot, being able to explain kind of what you're doing in the plot. So a scatter plot is a graph of a set of data pairs used to help you recognize. We're looking for patterns and make predictions. So in a scatter plot, we look for the pattern, we make predictions. So with that said, we are going to go ahead and talk about what an ordered pair is. So ordered pair, we talk about the elevator analogy, hotel analogy. So we find the elevator first. So left and right movement first, because you have to find the elevator before you can go up or down. So then after you do that, you'll go up or down on the elevator. So left negative, right positive, find the elevator, up positive, down negative. So if we look at this first example, we talk about the ordered pairs that are on here. So this one we would say, this one's probably a perfect one to look at. So we're going to go right 7, find that elevator. So our elevator would be located at 7, then get on the elevator and go up to this value here, which looks like it's halfway between 70 and 90, so 80. So a test score of 80. So in right 7, up 80. So if we were to put some labels on there, we're really saying that if you study for 7 hours, you should get a score of 80, which is a B minus. So 7 hours of studying would give you a B minus. So what the pattern would be in this problem is the more you study, the better you do. So as the hours that you study increases, the better the test score. So we could pull out some data points. Let's go ahead and pull out more data points than that. So let's start with saying we said 780. 7 hours of studying. 7 hours of studying is a test score of 80. So what's another example? Well, we can, and I'm going to have to kind of estimate on some of these because they're not great. But if we go ahead and look at maybe this data point here, 6 hours of studying is a test score of 70. Let's do another data point. Now I'm going to round probably this one a little bit, but 3 hours of studying is just slightly less than 60. So 3 hours of study is maybe like a 58 on a test. So you can see the more we study, the higher the score. As hours studied increases, the test scores also increase. All right, so things that we need to remember in this lesson. The first thing is that the squiggle on that we would do. So this squiggle right here on the x-axis basically means that there is some of the scale has been skipped. So we call that in math a break. We have to break the graph. We talked about that a lot in 7th grade, where we break the graph and we say we're going to skip from 0 to 50 and then we're going to scale from there. Okay? And then after we do that, the interval between the lines has to be super, super important, constant. Has to be constant. So as we look over here, we see that the interval, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. We're going by ones here. Over here, we break the graph, we jump from 0 to 50, and then we scale up by tens the entire way, up by tens. So that scale, we're going up by tens over here on the y. We're going over by ones here on the x. It has to be constant. So in your work, in your homework, you're going to have to be able to graph those points yourself. Now, I assume that you know how to do that because you've been doing that since 5th grade, plotting data points. Remember the elevator analogy, checking at the front door, the origin, left and right movement first, find the elevator, then go up or down, label the data points. Make sure we put titles on. Make sure we watch our scales. My answers are all over. They should be on my website right now, unless a mistake occurred. So make sure that you go check answers if you're struggling. Don't forget title and labels. That was available to you on there. The space between the lines has to be constant. Totally has to be constant. And don't forget, or don't connect. Do not connect the dots on a scatter plot. They are scattered on purpose. We're looking for a pattern. Looking for a pattern. And then finally, whoops. And finally, remember that you label the line, not the box. So make sure that you're putting the numbers on the line. And remember that that's on that horizontal axis. We want to make sure we have that horizontal axis and the vertical axis. So you know what? For the sake of getting started, I think I'm going to go back. Let me finish up on the notes there, but I think I'm going to go back and start graphing one of those on page 12 to get you kind of started on what to do since I'm not in class with you right now. So when you finish this, if I'm going too fast, you can pause the video. I want you to move back to page 12 so we can graph this out. All right, so on page 12 on the bottom, let's make this scatter plot that you compares the seed size and the plant height. So you plant the seed in the ground, how tall will it get? Let's put seed size on the horizontal axis, it says. So we're going to go ahead and say, let's put seed size down here. Seed size. So for our title, we're really comparing these two things. So I think I'll use that as my title. I'll say seed size versus plant height. Seed size versus plant height. The seed size is measured in millimeters, and the plant height is measured in centimeters. Okay, so working from left to right here, the seed size, we range from 3 to 11. So we'll see if we can fit it. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can't fit it. So instead, I'm going to have to think about how I want to graph that. I think I'll actually probably extend the graph out. Go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to squeeze out 11 out here just because I really want to stretch that graph out. Notice my scale is I'm going by ones there, going by ones. For my plant height, I'm ranging from really 100 to almost 500. So I need to get that scale over here as well. So I think I'm going to have to decide, can I go by 25s, 50s, 100s? 100s would be too small. I'm going to start at, I think I'm going to go by 50s. So 50, 100. So this is the plant height. 150, 200, 250, 300, 350, 400, 450, 500. That should do it. That should be able to get all the data points on the graph. Go ahead and take care of that if you will, please. All right, so as we start to graph, putting those data points on the graph, we would go ahead and say, so we don't have any data points at 0 and 1, but we have a seed size. If we put a seed that's 3 millimeters, 3 tiny little tick marks in the ground, the plant's going to be 101 centimeters in height, or at least that's what we have for our data collection. Maybe it's not always a guarantee. So we're going to go over to 3. So here's our elevator at 3. We go up to 101. Over to 3, up to 101. Again, it's a little bit of a guessing game because we don't have a perfect 101 on our graph. Slightly greater than 100. Elevator over to 4, up to 107. Over to 4, up to 107. 5, over to 5, up to 115. Over to 5, up to 115. Over to 6, up to 175, which would be about halfway in between there, 175. 7, over to 7, up to 280. Over to 7, up to 280. 8, over to 8, up to 375. 8, 375. 9, over to 9, up to 423. Over to 9, up to 423. 10, no 10 on the graph at all, but 11 up to 475. That's kind of off my graph. I stretched it out on purpose just because I wanted to make sure that I could stretch this graph nice and good. So there is what I have for my data. So I have titles, I have labels, I have scales, I've done everything I'm supposed to do, I've spaced it right. What pattern do you notice between the seed size and the plant height? Well, it looks as the seed size gets bigger, as the seed size X gets bigger, the plant gets taller. So we say as the seed size increases, plant height also increases. So that's what we call a scatter plot. Again, you need title, you need labels, you need to plot the data points. If I went too fast, go ahead and pause the video. But your job is to do the 2 scatter plots on page 13. Please take your time. Make sure you scale it right. Answer keys should be available on my website if you need some assistance. Also, in number 3, you're going to end up having 2 different scatter plots. It's recommended that you use 2 different colors. One for the men's freestyle swimming and one for the women's freestyle swimming. Sometimes it's best to color code those so you can see the difference between the 2. If that's not available to you, you could use different symbols. Like you could do stars for one of the data points and circles for the other, something like that. Okay, finish those 2 problems on page 13. Have a fabulous night, 8th grade.